Hello guys, today is time for my new tutorial. Today we are gonna be dealing with a few few ideas about lasers. So I'm gonna create a 2D player that shoots the laser, and that will be controlled by the mouse. So I'm gonna do the left mouse shooting, right mouse moving, or so. And then we're gonna create a burning flame. We're gonna spawn a little flames where the laser is gonna aiming at, uh, and then we're gonna attempt to save and load the game with the JSON utility, with the built-in utility that Unity has in itself. Alright, so let's jump directly to new project, create a new project, and as you see I have a few items already here. So the first, this is a default, I saved the scene, the default save scene, and in the asset you can see a prefab, already made prefab. So this is the hotspot. So I'm gonna just to show you, I'm not gonna tell you how you create a particle system. Alright, so this is a particle system. You create a particle system, and then you play with all of these variables, colors, speeds, how the particle is gonna emit, how to show. The main thing is, I'm just gonna delete this, that this thing here is gonna be the flame where the laser is gonna burn on the ground. So one important thing here is that the prefab, you should make this on loop. Okay, so not this thing is looping forever, so we need to unloop. That's the thing we need for this tutorial. So I'm gonna just leave to you to create your own particle system that should be representing the burning flame. So I'm just gonna delete, and later on we are gonna add this hotspot prefab to our script when we are gonna spawn the fire. Alright, and the next thing is you need to create an actual laser, an image that's gonna represent the laser beam. So let's show in Explorer. So this is the laser. So you can do in a simple paint application. The main thing here that we're gonna need in our math later on is the length of the laser. Okay, remember the length in the laser in pixels, in pixel units. So in our case is 71, 13 on 71 width and height. So we need the height. Alright, so first thing, let's create the player. So create empty object. We're gonna name it player, and so we're gonna create a sprite renderer, and just for a simplicity I'm gonna create a simple square player body. Alright, so this is the sprite of the player. Let's put the body. Here it is. I kinda hate when it's not a 0, 0, 0, so let's set this straight. And we're gonna just resize a bit to look like an actual laser. Okay, change the color to, I don't know, some green body. And probably I'm gonna just create, drag and drop into the player a new a new sprite, which is immediately created in the game object, and game object is in the parent, is the child of the player, and just gonna create this more like yellow thing, which is gonna be the barrel of where the laser is gonna shoot. And you're gonna set the ordering layer into -1 to show below the main body. So I'm just gonna move this like this. Alright, so we have quite a bit, 0.25. So this thing here is the representation, the 2D representation of our player, our laser. So now let's put the functionality. So create an empty object, make it the child of the player, and this is gonna be called a start point. And also we're gonna need duplicate an endpoint. And why is this? This thing here are gonna be our 2 points for raycasting. So we are gonna raycast from start to the end point, and we actually gonna be doing a line casting in the script just in a minute. So let's position this first. Where should this be? This should be at the start of this barrel. Well, let's name this player shooting, I don't know, a player shooting barrel, and start point is here. The end point should be somewhere off screen, and make it sure is the length of the diagonal of your whole screen, at least this long, somewhere here. And why is this? Because if you put here the player somewhere here, and the laser should be rescalable all the way to fit the screen, to not be limited on, to be everything as normal. So let's make this 0, 0, 0. And now the main thing, the laser. The laser, one thing for the setup is that it needs to be a sprite. Probably you already know that. And the main thing here is the pivot point. So click on the image and click sprite editor, and here this is the pivot. So this pivot point, you need to set it up to bottom, to be here. Once it's done, click apply, applied, and now just drag and drop to be the child of start point. Okay, here it is. We're gonna rotate this to -90, I guess. Yes, exactly. And to be with scale of 1 and 1. And just reset. Yeah, just do after your parent, just do a reset and then scale the thing to -90. And so we need this laser to, when we shoot with the laser, let's make it with more width, like 4. Maybe this is too big, like 3.6. Okay, and all we need to do now is to with the mouse button, when we press the left mouse button to activate the laser, and when we release the mouse to stop emitting the laser. But when we do emitting the laser, we are shooting actually, and we need to rescale this length here. Depends on what it hits. And when we're speaking about hits, let's create a wall, some random walls. So actually let's use this sprite. Just gonna rename wall. Though let's position somewhere random. Create walls, and I'm just gonna multiply, and I don't know, put it somewhere randomly, just so that we have something that we can collide with, some game level. Okay, so I guess here, and we're just gonna move like this. Oh, I'm sorry, and we forget to put a collider. We need that. So physics 2D, the component box collider. Alright, so there it is. And now we're gonna duplicate randomly on the scene. Maybe just one more. Okay, let's say this is it. So make sure we save the scene. Alright, and let's create the main script now. So on the player, we're gonna put it on the player, new script, laser dot script. Double click it. Let's wait to Visual Studio to load up. So here we are, a fresh new script, and I'm gonna just include one more namespace. This is using system.io, and this is later for the JSON reading files, saving, loading. I'm just gonna include now. And the first thing we're gonna be declaring some variables that we need. So normally the main variable here would be a private vector2 mouse position. Okay, so we need a coordinates of our mouse. This is where we store the mouse coordinates in vector units, because the input dot mouse, I'm sorry, this is out of function, input dot mouse position, these are in screen points. The next thing would be the public transforms on array of point, and these are, so let's save, and these are the points that we all already created. So let's wait the update. Yeah, okay, here we are. These are the 2 points that we are gonna put using the inspector, and so this is the start point and the end point. Alright, so we're gonna be line casting them from start to end, so we need them to reference in the line cast function. And speaking about the laser, let's create the main laser, public transform laser. So this is the main object that we are gonna rescale. So this is actually the child from this script, this script the game object is attached to. The next public thing would be the hotspot prefab, the burning flame. So let's create now a game object that we are gonna instantiate later on at where it burns. So prefab, let's name it prefab hotspot, I guess. And we need a private reference to the sprite render of the laser, of this laser here. We're gonna get that component. So sprite renderer super laser. Then we're gonna need a raycast hit 2D reference to our hit object. And for the movement of the whole player, we're gonna be needing a target position. So move target. So this is the position where the player is gonna move at. And some bool restrictions for our shooting. So bool fire, it's equal to false. So we are not shooting. And we're gonna create also a coroutine. So we're gonna be needing a coroutine fire equals to true. I'm gonna explain later on why this is true. There is probably a bunch of more variables for our saving and loading the game with JSON file, but that's going to be in the part 2 of my tutorial. For now, this is all we need. So let's move to our start function. And in our start function, we're gonna say sprite laser. Remember, the component we need to get is equal to laser dot get component sprite renderer. And immediately, because when we start, the sprite renderer should be disabled because we're starting with unfired position. The fire is false. Okay, so when the game starts, the laser is not active. So in sprite laser dot enabled equals to false. And one more thing, let's initialize the move target to be equal to vector 3.0. And speaking about the laser, we forgot to put all these things. Let's update the script. Okay, so the laser, the reference for the laser should be image laser. Remember, the main thing. And a prefab, our hotspot prefab. There it is. We have it all. Once again, file save the scene. Let's go back to the script and let's jump to our update function. Okay, so first thing we want to do is to get a conversion from screen space points to world space points, these mouse coordinates. So that would be mouse pos equal to camera dot main dot, and this is the function screen to world point, and here it expects a vector 3 position, and that would be input dot mouse position. I think the mouse position is a vector 3. All right, in this version is vector 2. I remember it was a vector 2, but anyway, okay, it's fine. And now we have the mouse position in our world coordinates. The next thing we want to do is creating a a temporal vector 2 direction variable that's gonna calculate the distance, the difference between the mouse position. So it's where we wanna shoot the laser, we wanna go. In both cases we wanna do something with the mouse, so we need to get the angle and the position and the distance, everything that we're gonna do with the mouse. So mouse minus vector 2, let's explicitly recast the transform position at we currently at. Remember, this all script is on the player, so this transform position is vector 3. We're gonna implicitly cast to vector 2, and probably you already know that if you want to normalize this vector, you can do. I always normalize this vector. It's some of a practical use. You don't need to. It's fine. We need just the difference from where we are to where the mouse is. But I'm used to normalize this vector to be with the size of 1, the length of the magnitude of this vector 2 to be a 1, and then I'm gonna do whatever I need further on. And further on is to calculate the angle. So float angle, again a temporal value, float value, where we gonna get the angle of the player that we need to rotate after, depending on where we are with the mouse position, and that would be the well-known function in mathf class, arcus tangens, namely set atan2, and here we need the direction epsilon divided by direction x, and yes, this is input parameter, but what this function does is dividing this epsilon with the x component of the angle, and that is the tangens function. Arcus tangens is getting the angle that these two lengths do each other, but how this thing is in radians, so we need to change in a degree. So instead of typing 180 f divided with p, this is the thing, but we have already this coefficient, this constant in the mathf class, and that is mathf rad to deck. Okay, and that's it. That's all we need to do. And when we already have the angle now in this frame, okay, so this is happening each frame, 60 frames per second in real time. So this, we just need to rotate, to update the rotate of the player. So transform rotate dot rotation, and of course it's gonna be quaternion, so we play with quaternion class, responsible for any kind of rotation, and we just simply gonna use this Euler function. So here it expects a new rotation every frame, so we have a new vector 3, and we don't rotate around x, so we have a 0f. We don't rotate around epsilon axis, so we have a 0, and we do rotate around z-axis, so we have just simply z angle, and that's it. Let's file and save. So this is like a motor, a standard code for to get the angle from the mouse position in the game. The next thing would be the physics 2D line casting. And so remember this guy here, ray casting hit 2D hit, so it's time to use this. So we're gonna line cast, I'm sorry, from start point this. So let's actually create some of this. Okay, so from this dot to the endpoint, and that would be this dot here. Okay, from this to this, and whatever object it catches, it's gonna represent this hit object here. So if it hits this valve, for example, we're gonna have the distance and everything else, the transform, the collider, everything that this laser is hitting at, is colliding with, and we need to resize the laser depend on what we hit. And if we don't hit, we're just gonna make the laser go infinitely, but and what I mean by infinite is I mean out of the screen somewhere to this point, to look like it's shooting to an infinite space, somewhere deep space, but we don't need that. That's unnecessary. Okay, so let's continue with the scripting. Hit equals to physics 2D dot line cast, just simple line cast. It expects starting and end point, and that would be our point, in this case the first one, dot position. The second parameter is the endpoint, point 1 dot position, and we need to put which layers this line cast it's gonna be activate against, and we're just gonna say the physics 2D default ray cast layers, and this means it's this hit, it's gonna collide, it's gonna detect collisions on all layers, all these layers you put. That's the default raycast layers. But this one, if you put an object, ignore raycast, it's not gonna be hit, it's not gonna be catchable within this function here. So we are all default set up. You don't have to worry about anything, change anything. This is the default way the Unity is set up, so we just continue with the script. Okay, so let's make a short debug log. This is to see if the hit distance actually work and how much it is. So we're just gonna debug this variable, this distance, and finally the main moment of the script is when we resize the laser itself. So we have the reference of the laser, which is child of this script. So laser.local scale, we're gonna rescale to a new vector each frame, to a new vector 3 each frame, and the X thing, let's switch the scene. Okay, so this is the laser. Let's zoom a bit. So this is the X scale. The X scale is what we set up in the inspector, so 3.5, and we're just gonna leave that width to the laser. So laser dot local scale dot x as it is. We don't change, we just pass the parameter. We do wanna rotate. I'm sorry, we do wanna rescale on epsilon, so I'm just gonna a second leave an empty parameter, and just on z we don't do anything. We just simply say 1f as it is. Z is 1. We're just passing that. And here the main thing, in this parameter we're just gonna type a ternary operator, a ternary condition, and that would be this: if hit distance is lower than 0.01, then if it is, that means it's an infinite, and we just rescale this to 20.25 float value, and that is off screen. So this is when we don't hit anything. And why is this? Because why do I put this line? Because in Unity we can equalize float. Okay, it doesn't work like it's always gonna give a false because it's a floating point number. That's how the guys of Unity decided to do this. So instead you play with tolerance. So this is roughly around 0, and when the distance is below this it means it doesn't collide anything, which means actually it's firing to infinity. And if it does, then we just rescale the laser to 25, and let's see how that would be. So create epsilon 25, it would be this much. Okay, so let's return back to 1, and if it actually hits something, then the next part of the ternary condition would be a hit dot distance divided by 0.71 f. So I have to explain how I get this in the next few comments. So stay with me. It's a simple math equation. So I'm just gonna type the math thinking behind rescaling. Okay, and that is this thing here. Current. Okay, this is just in the text. Current local scale of the object divided by real pixel width divided by pixel per unit value. Okay, so I'm putting this in small brackets to be equal to our wanted length divided by our hit distance we get from the line cast. Okay, and what is this here? The current local scale would be replaced with the actual 1. In our case, we just put 1. Okay, the current local scale, this laser is 1. Then we say real pixel width divided by pixel per units, and that means if you go to our image, you know that the pixel pixel per unit is 100, and our real pixel pixel from the image is 71. That's why I've told you that the pixel length of the image is important. So if we change all of this, we get 1 divided by real pixel width 71 divided by 100. Okay, and this 71 divided by 100 is actually 0.721, so we get 1 divided by 0.721. It's equal to our wanted. I'm just gonna copy and paste this, and from here, this is a simple equation. We want to get this wanted length, and that is wanted, sorry, I'm forgetting the comment, wanted length from here is what is hit dot distance divided by 0.71, and that is exactly what we have here. Okay, so that's the math. It's not a big deal. Once you know what I'm doing, you will get along. Okay, so let's file and save the script, and we continue with the actual inputs from the mouse. So we say if input dot get mouse button down, and which mouse, the 0 is the left mouse button, a 1 is the right mouse button. So we play now with the left. What happens if we press the left mouse button down? It means that the super laser component, it's true. That means the fire is active. Let's activate the sprite to be visible for the player. And the bool, we set this to true. The laser is active, so fire is equal to true. We are firing. And I'm just gonna copy this. What happens if the mouse button, the left mouse button will release? So get mouse button up of 0 is gonna be false, and the fire it's gonna be false. So we release and the laser stops. Okay, that's what it is. And now let's deal with the right mouse button. The right mouse button is for moving the actual player. So let's just stop with the laser. Now we play with the player movement. So if input dot get mouse button up, so when we release the right mouse button, then we say move target equals to mouse position. Okay, so the place we want to go is where our mouse is currently. So from our position to the mouse position, and that mouse position is converted here already in the world coordinates, and all we need to do is assign that coordinates to our new target location, this move target variable we created here. And once we have that, we are still in the update, so we are just gonna, like from the previous tutorial I had, we're just gonna type transform dot position equals to vector 3. We're gonna lerp this thing from target position we are to simply move target location at speed of 0.2 f per frame. That's all we need to do to play with the mouse with the player movement, guiding it from the mouse. Again, file save. Okay, so the next thing we wanna move to is the burning flame. So actual spawning of the little flames of the hotspot prefab. For that purpose, we're gonna need a new condition. So we're gonna say if hit dot distance is greater than 0.05. Again, it's the same analogly to this thinking. Now if it's great, then it's actually hitting somewhere, and if it hits, if this is true, and fire, remember the fire, and if the fire is actually activated, then we just gonna create a coroutine for this spawning, this time prepared spawning, but we need a temporal bool that's gonna check if the coroutine is activated, and when it does finished, this bool is false. So if coroutine fire, then we just start the coroutine, and we're gonna name this coroutine function spot flame. Okay, and we got error because we don't have still the coroutine function. So out of the update class, we're gonna create the coroutine spot flame, and here we say if this coroutine is true, which is true, stated by default, coroutine is true, then this will start the coroutine spot flame. Okay, and in the function spot flame, we need to set immediately that coroutine fire to false. Okay, just off it, close it, to close this if, because this if is actually in an update function that's gonna update constantly. So temporarily just off this bool, false this bool, and just then spawn some game object. In our case, it's gonna be the prefab hotspot game object. This prefab we add, and at location of hit point. Remember, it needs to be at where the laser is hitting, and just the rotation would be the default of this object, quaternion identity. All of this as game object. Probably I don't need this. If you need to edit, if you need a reference to this hotspot immediately now, probably I don't need these parts, but I always do in case I do other things. But you don't have to do it. It just instantiate this. This is enough in your project, and then we're just gonna wait. Wait for seconds till the new spawning occurs to 0.015 part of the second, and when that happens, this is fairly fast, then we are gonna just enable this the previous bool coroutine file to be true, and when it's true, this is gonna loop back and forth. So this is true, and now it's gonna catch here, and if you press the fire, and if actually you are pressing the left mouse button, you're shooting, fire is equal. This is true, and again the start coroutine is gonna start, it's gonna be again false, and again spawning little hot spots, little burning flames at the hit point, and the hit point is actually where the laser endpoint is. This here is aiming at, so it should be on these lines here, on the walls of what we wanna hit. So that's all you need to do for this script for now. Let's file and save. This is it for this script, but we also kind of need to this hot prefabs, these burning flames, to die over time. Remember, because they are not set on looping. I clicked this previously, so this hotspot is not looping, so it's gonna fire off, it's gonna finish its animation once this particle is done, but the object it's gonna be there. Okay, it's not gonna be visible, but it's gonna we will have many objects that's just gonna sit there. So what we wanna do is just create a script. Okay, new script here, C#, and we're gonna name that behavior, right? I guess I spell it behavior. That behavior. Open that script, and in the start function we're just gonna call destroy ourselves, destroy this game object after I don't know, 2 seconds. It's gonna, every object, every burning flame, it's gonna be destroyed by itself. And this script we're gonna put at this prefab, that script. Yes, exactly. So there we have it, and now the hotspot know for itself that needs to die after 2 seconds. Probably we're gonna change it 2 seconds if it conflicts with the animation of the particle system. And just for in case, I'm just gonna reapply. I don't know if Unity sometimes in previous version it didn't update it very well. Okay, so let's actually file and save the scene and test this whole thing. Okay, as you see here it is. The player is rotating. Okay, so I'm just gonna click and move. Okay, as we see, it's moving where I want, and now shooting. Alright, it's spawning and moving, it's working, but you notice that the laser, it's actually longer than the wall. It should be correctly resized, and this is because we resized the parent object. Remember, we are dealing with childs and parents and resizing, so all you need to do is to select the player and just make this 1 and 1. Of course, we have a changed situation here, but when we press play again, we will notice that now it's so perfect. The laser is nicely represented, and actually let's create this laser to be something like red properly. Okay, here it is, the laser, nice layout. And again, if we press, and probably we need to put the whole player to be on 10 ordering layer to sort the sprite render above the wall, so when we press it's above, and actually also the barrel to be 9. When we go, there it is above the wall because it's the player, we are the main thing. And let's unzoom and shoot. You notice that the off screen is actually limited. Is exactly 25. If you see the epsilon here, it's 25 when it shuts on infinitely. When it collides, and actually let's see the console, there it is. We have a lot of, let's clear a bit, and if we're shooting and the distance is changing, now we're smaller and then it's greater. Yes, everything works just fine. So that's for this part 1 of the tutorial, how to create a laser attached on a player. We're shooting and moving the player, and now we're gonna attempt to use the JSON file, JSON utility, to create a file to save, just for the simplicity of how to use a JSON utility. We're gonna just save the location of this player, and then we're gonna attempt to load the last location, and that is to load the last previous game.